presentation is from Pam Bowers. Pam, if you just want to tell us who else was in your group and what question you were investigating. And then go ahead, take a few minutes and tell us what you got, and Catherine can drive the presentation.
Okay, actually, I went ahead and I tried to answer the question based on some images that I just recently received. So the people that are in my group, I'm not, I'm not seeing that right this second. So
okay, go ahead.
Okay, so okay, what I did is that I had a lot of images that came back very grainy. So I was trying to see whether to increase or decrease the exposure. And so I used, and I'm going to try to get, Dave, you want to run this Prezi? I don't know if you can run, we can't run it from here.
Yeah, just hit that full screen button there on the right, and that'll make it big for everyone.
Yeah.
There we go.
Okay, does that help?
Yeah, thank you so much. And so there it is. That's the most grainy image of the three that I took. Of course, I tried the Horsehead Nebula over and over and over again. I had lots of issues with that. So I never really did figure that one out. So I gave that a grainy rating of 2. That was the most grainy of the 3 images that I got. The next one, and you have to do it, we're going to move to grainy rating 1. And as you can see, 1 is less grainy. We can start to actually see the image that we wanted. And then the third one had a grainy rating of 0. And there it is. Yay, finally an image through all of that mess. So what we did, and what I didn't put in this Prezi, was I should have shown that there was less of an exposure time, which corresponded to the least grainy. Okay, so this had the least exposure time. So, and the next one shows, that's just a statement that I put in the Prezi. How did exposure time affect graininess? And in this case, when I decrease exposure time, it decreased the graininess. Sorry, it's not more complex, but that's what I quickly did. So, and that was just me personally.
Were your images taken on the same night or from the same telescope?
Same telescope, same night, different exposures.
Cool. That's a good experiment.
How about filters? Were they the same filter, Pam?
They were all the same filter, because what I had experienced with the Horsehead Nebula, I was going through a lot of different filters. I wasn't seeing a lot of difference. It probably was something else I didn't have set correctly, but so I just went with clear.
Okay.
So my next step would be to introduce some filters and see if there's any changes there. And there is nothing else then after that.
Good.
Well done.
I think that's a good job.
Yep.
Thanks, Pam.
Okay, thank you.
Yeah.
Does anyone else have any questions for Pam?
Hi, Pam. Did you end up trying different filters on the Horsehead Nebula, and what did you find how did you find the filters affected your image?
Grainy, and grainy. I tried a lot of different filters. Oh, yikes! I'm jumping all around with the exposure time, so I just didn't ever get a solution there. I think probably I'll try it again just because I want to see if I can complete an actual image that I can see. So I think it's just going to take more time.
Any other questions?
What was this one a picture of?
So that spiral galaxy that we're seeing in the center right now, what is that again? Can you remind us?
M82, I think.
Yeah.
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 Okay, so Pam, this is Vivian.
Hi, Vivian.
Hi, how are you? You know, we're really glad that you're in our class. So, and thanks for doing the cool Prezi. I just tried to look up your images. This would be the ones that you did for M86, and you used 0.2 and 0.5 and 10 seconds. Is that true?
Yes.
So it's
846594.
Okay, so I'm looking at them in Afterglow.
Yeah.
And the 000 image looks like the last one that you showed.
Yes.
And that exposure length is 10. And then the 0.01, which looked like the middle one, the exposure length is 0.5. And then the 0.02, which was your first one, the most grainy, exposure length is 0.2.
Can you hear me?
Yeah.
Okay. So what I must have done is I must have just reversed it.
Yeah, I think
I'm
that's
sorry.
yeah, and that's easy to do.
Makes sense.
Mm-hmm.
Yeah. So
Okay.
it's just opposite. Is what you're saying, right, Vivian?
Yeah, I'm saying that the most grainy, I think had an exposure of 0.2, and the least grainy had an exposure of 10.
Yeah, we were pushing this Prezi out the last 5
No,
minutes.
that's okay. That's okay. I just wanted to see if you still agree with yourself.
Yeah,
if,
definitely. Thanks for bringing that up.
No, it's really cool that you made the Prezi, and I love it.
Vivian bailing us out. Thanks so much for bringing that up.
That's what a science conference is all about.
And here it is, yes.
And here it is, yeah. Cool. Sorry for the noise in the background. It's my steam heat. I'm going to turn down the heat so it quits singing to us.
Anyway, that's exactly right. Vivian is right again. And thank you for telling us that.
I couldn't have figured out the Prezi. So if you hadn't done the Prezi, this conversation never would have happened. So.
Exactly. Anyway, I really think that this is a good way to use this. Whole project is to have this discovery process, this inquiry process. This is very cool, and I think kids will really like this. And there's a bevy of questions you can ask on any of these images, so that's really good.
Great. Thank you, Pam.
Thanks.
Any volunteers who wants to go next?
Anna, should I turn over controls back to you?
Let's see who volunteers next, and then
Okay.
And then we'll do that.
Okay.
Anyone? I know that Kathy is not on. Is Tom there? Or anyone from Tom's group?
We can come to control panel.
Well,
It looks like
I'm here. This is Jen, and actually, Tom and I are in the same group, so we sent
great.
it 2 different versions of the same group info.
So Tom's phone's not connected. He probably it's either
Oh, I see.
Oh, there. I just unmuted him. I could do it.
Hello.
I don't know what the.
Oh, hi.
Oh, there
Sorry,
you
Tom.
sorry, you were muted. I guess I
I'll
just
unmute
noticed people have joined.
I made up something for that pendulum activity, and I'll
Yeah, Jen. we sent in some stuff late, so I don't know if you got it, Anna, or not. But Jen put together a little PowerPoint, and
I received yours and Jen's. So do you want us to pull up Jen's?
Yeah, pull up the PowerPoint. It's the same info in a little nicer format.
Okay, let me get that opened up here.
All right, I'm turning the control back to you.
Great. And I'm going to go into slideshow mode. And whoever wants to speak, you can take it away. And just let me know when I should advance the slides.
Okay. So in our group, Jen, myself, Mary, Meg, Katie, and James. And yeah, we had a time pressure this week. A lot of people were very busy, so we did the best we could. And nice of Jen to throw together the PowerPoint at the last minute here, so a little easier to see. Mine was would be pretty hard to read. So anyway, yeah, here's the original question that our group was assigned or volunteered for. How does the brightness of different stars compare in different filters? And then can we measure the temperature of stars by comparing them through the different filters? You can go to the next slide. Okay, and here are some preliminary results. And I chose these images, and you've got one later that is Jen's from M83, the galaxy. But so breaking them down into stars that you can see the color of, or at least the apparent color with the naked eye, we've got blue, blue-white stars, yellow stars, or red stars. And these are pretty bright, so what we had to do was use the shortest exposure possible. And the images aren't much to look at because they're just individual stars. And so some of them, even with the low exposures of a tenth of a second, or the lowest I found we could go was 0.03 of a second. I don't know if it's possible to go lower than that or not, but on prompt 3, which was the scope I mainly used for these, 0.03 of a second was the slowest you could go. So when we select other stars to see if our theory or hypothesis holds up, we'll use dimmer stars, no doubt. But anyway, this still works using, even with overexposed images, you could point the photometer at the center of the image and still get a flux reading. And so this is pretty much what you would expect. The blue-white stars had a much higher value through the blue filter. These are astrophotography filters, by the way. And the red stars, much higher values through the red filter, so they were brighter in that wavelength. And the yellow stars, what I was finding is these may not really be what you'd call yellow stars. They might actually be, well, Capella I think is a G, and Pollux I think is actually a K. And I did re-image Capella and Pollux using the other filters, the BV and R filters, and it still came up, those two stars at least, still came up with higher values in the red even compared to the visual, which is supposed to be a yellow filter. So anyway, these are the raw numbers. And if you look, one real interesting one I think is the R Leporis, because that's one of the reddest stars you can see with your eye or your telescope.
Yeah, that's amazing.
Yeah, really heavily red and very little blue by comparison. You can go to the
Did you use
next.
the same exposure time for each star in the red and blue filters?
Yeah, well, I started with the same exposure times, which were 1/10 second, and then when I made a couple of later requests, I went down because they were overexposed. So I listed that in my one-page RTF document, the exposure times and telescopes, but it's not here in front of us. But yeah, certainly for a given star and the given set of filters, the exposure times were the same, of course. And the images were taken same telescope, same night. So for instance, for Regulus, it was prompt 3, and both red and blue filters were shot at let's say, 1/10 of a second. And pretty much right after each other, the way the images ended up being taken.
That's really good. I like the numbers.
Okay, and then the next one will show kind of what we're thinking then, where you could go from here.
Just a moment. There you go.
I think it's the next one.
Is that the right one? Example
Nope,
image?
I'm still looking. Oh, there we go. Okay, so there's
Okay.
a couple of examples, yeah. And again, they're not much to look at. You can see the diffraction spikes and the overexposure, but even so, if you point the photometer tool right at the center, you get a value at least that's, I think, relevant for comparison purposes. And you could go to the next one. Those are two really bright stars, of course.
So for this one, I actually wasn't getting a lot of, I put my photo requests in late, and so I hadn't gotten anything good. And these were my requests for the color image and putting that together. So this is the only one I had in 3 different filters. So I thought, well, I might as well look at this in terms of the photometry reading. So this is M83 and taken from the prompt SSO2 telescope and in R prime, G prime, and I prime. And with the photometry tool, I just looked at the center of the spiral galaxy in each of those images and to compare those, the magnitude and the flux. And in the image we're seeing over to the side is just the RGB image I made in the Astro program.
Did you try any of the stars in that in your image through the?
I didn't. I could go back and do that. I guess the only thing that was really stopping me is I couldn't find any information about the stars around, and in terms of because I was looking up sort of the magnitude, the apparent magnitude of M83 and some of the information I could find online about it, and since I didn't know what those stars were, I didn't look at them in particular, but I can, well, I did look at them, but I guess I didn't record down any of my data from that. But I guess using my image, if I did it correctly, I could use the apparent color in that image and then go back and look at the photometry, using Afterglow.
True, yeah. Yeah, because you've got your 3 colors there.
And then I think the next one kind of summarizes where we're at.
So with just while you're going to the next slide, Jen, if you did the center of the galaxy with your bullseye, your photometer bullseye, with the outer circle was also still had galaxy in it, right?
Yeah, I guess I used the brightest part of this and compared the center of each of that because that was an easy target in terms of X, Y. But and in the reading that I was doing, they were saying a lot of the outer part has bright blue stars within it and some star formation that they've discovered in the last couple years. So as long as I was pretty careful about the portion I was collecting, I could make those comparisons too.
Right.
And then this one just kind of summarizes what we think. So for any star, and of course most of them look white, using these filters you should be able to tell whether the star is shining mostly in the red, yellow, or blue part of the spectrum. And so we should be able to, at least roughly and relatively speaking, tell the temperature of the stars just by imaging them with different filters and then applying the photometry tool. And probably I started out with the astrophotography filters for this kind of activity. Most likely the Johnson Cousins BV&R filters would be a better choice going forward.
And what makes you think that?
Well, first of all, you've got the V filter, which is letting through yellow light, and you don't have a yellow filter with the astrophotography.
Okay.
So to get a mid-range of wavelength. I expected Pollux and Castor to then be emitting, or get a highest photometry reading with the V, and that's not what happened. They both were still highest in the red. So that'd be fun to kind of further explore.
Mhm. Cool.
Did any other further questions come up as you were investigating this? Other questions you want to investigate?
Well, I think just, actually trying to apply what we see in the pattern here and see how far we can go with it. I don't think you can narrow it down to actual temperatures, but you can certainly tell whether a star is more red or more blue and get a rough idea, relatively speaking. So I'd like to try it with, I don't know, maybe a cluster of stars and get a bunch of different stars that you can't immediately, get any kind of idea of their actual temperature, and see if we can guess, and then look up the actual values or the actual spectral classes and see if we're right.
Great. Anyone have any other questions for Tom and Jennifer?
And thanks again, Jen, for putting that together.
Yeah,
You have one question.
I wanted to compliment Jen on the PowerPoint too. Jen, did you use? Looks like that in the background is a M42 image, all kind of made pretty.
In just like the general background, well,
yeah.
I grabbed it from PowerPoint, and it's called Celestial, so I thought it was fitting.
Yeah, I think it's actually M42 and M43 back there. I thought maybe you grabbed one of the images that somebody made, but yeah, it's that's nice, but it's very nice. But the other, I just wanted to compliment this group. This is a big question, and there's a lot of you can go really far with it. And you guys just jumped right in there and took some images and got some data and, made it quantitative. So good for you. I enjoyed working with your group.
Thank you.
Thanks. All right. So why don't we move on to the next group? And Lacey, try talking now and see if we can hear you.
Can you hear me now?
Yes. Sorry about that. You may have been muted before. Are you excited to share the presentation? Do you want to go next? Oh, right. And it's the one that Chris sent in, is that right?
Yes.
All right. Let me just switch over here. There's just a lot to download. It should come up. There you go. And for the little movie, I'm going to have to pull that up separately, I think, but we'll see how that looks.
I'm not doing that right now. Okay.
Oh, nice. I like the little print.
There, okay, I think we should be set now. So just let me know when you want me to advance the slides.
Excellent. Okay, I'm speaking for the asteroid imaging team, and you can see a list of all of our members here, and Chris is who created our PowerPoint presentation. He's really kind of a leader for our group, and he did an amazing job. And Vivian was a fabulous mentor. And we can advance to the next slide. So our initial question that we were assigned was, how does the reflected brightness of an asteroid compare in different filters? And so from that, we kind of had to start at what asteroids can we observe, as well as what sort of filters should we use with these asteroids. Advance, please. Next slide. So we first started out with the series Investa, which we found actually might be considered dwarf planets and not asteroids, but I just barely found this out actually from the presentation. And we also worked with Morrison and Parthenope. And the filters that we focused on primarily were the Johnson-Cousins BV, R, and I filters. Next slide. Here's a list of all the observations that most of the observations that we did as a group. You can see that we looked at a few of the different asteroids. We ended up deciding that the Ceres and the Morrison images were kind of some of the best ones that we were able to get. But we did try various exposure times as well as a few other filters and telescopes. Next slide. There's a little information about the Morrison asteroid. It was named for astronomer David Morrison and was discovered back in 1981. And information for next week, it'll pass within 1.1 astronomical units of the Earth. So big event coming up for Morrison next week. We advance to the next slide, please. And the Ceres is the largest object in the main asteroid belt, and it's actually going to be visited by Dawn spacecraft. And I think Chris was aware of this and thought it would be really interesting to get our own sort of data and then maybe compare some things that we learn from the Dawn spacecraft in the future when we get that information. The next slide, please. So we first worked through the first challenge of finding the right exposure time. So Ceres being much larger, we needed just a shorter exposure time. And even then, sometimes we would still have a little bit of the overexposure issues. And Morrison, we found the ranges between 60 and 80 seconds. And the Parthenope, which is really small, we would need up to 80 seconds just so you would get a fairly good exposure. Next slide. Locating the asteroid in the image, and this is actually our video with the bright asteroid. It's a little bit easier because you can just sort of compare images taken at different times, and this will be shown in this movie. Yes.
I don't think it'll play here, but I have it.
I think we just cut them off a second time.
Just a moment. I just play right in the email program here. Okay, so I'm playing it, and I'll quick play a couple of times if you want to talk through it as it goes.
Right, well, and it's just showing a picture of the images of Ceres in 2 different days. You can see the movements that helps you identify the asteroid. And this is fairly obvious, but we found it was a little bit more difficult to identify the asteroid as some of the smaller ones. And we can go back to the slide presentation.
That's pretty neat how you see it moving against the back.
Yeah, Charles did that. It's great. I think his movie maker inside of the image program. Okay. So to the next slide, it'll show how we were able to locate the asteroids that were much smaller. And so we've used the digital sky survey images for afterglow to do this comparison. You go to the next slide. And we had to find kind of stars that would match, but you'll see that we actually had to introvert and flip horizontally as well as vertically to get the images to actually match exactly. And the next slide, please. And so now we're able to align these two images together. We can look for our small asteroid. And so we're just looking for an object that in our image that we personally took that's not in the DSS. And the next slide, please. And there it is. So that's how we're able to find the Morrison. We go on to the next slide, please. So next we use the afterglow photometry tool to record the brightness of our asteroids in order to make a comparison with the different filters. We also used our reference star, which I don't completely understand. It was recommended by Vivian, and those of you who are awesome astronomers probably have a better understanding of the importance of using that and having a reference to do a ratio comparison between the stars and the asteroids. And we can go to the next slide. We'll be able to show some of the data that we collected. The first table is from Ceres, and we found that by far it was most bright with the R filter, and we actually found that as well. That was the same case for Morrison as well. And if you go to the next slide, we have some great graphs to show that as well. We found less with the blue or with the B filters and much more with the R. And the next slide. And here's just a little overview of, the filters, what sort of light and wavelengths you can expect. So we didn't see as much, the blue and violet side of the spectrum, and more in the green, yellow, orange, red area. You can go to the next slide, and I'll show the other filters that we used in the experiment. Okay, and if you'll go to the next slide, please. So here's some new questions that we have. Can we use our photometry data to calculate the magnitude of the asteroid? Also, does one asteroid reflect more light at a certain wavelength than another? And what other asteroids can we find? Some really interesting graphs that Chris also made was that he made the R filter be as what we would consider in the experiment the brightest filter. Well, it's the brightest for this filter, and then did a sort of ratio comparison with the other filters. So with R being 100% with Ceres, the B filter only showed 15% of that brightness, or about 60% of that brightness. And we're going to continue to try to collect more information from reference stars in order to understand better how the filters interact with how we can see the different brightness of these asteroids as well. And that's all I have.
Thank you, Lacey and Tom and the rest of your group.
And Chris, sorry, I referred to Tom.
Thanks for Lacey.
No, Chris, you're right. I was mixing them up too. Does anyone have any questions for this group?
That was really, really fantastic, you guys. That's an excellent science fair project right now.
Yeah.
Catherine and I are in the middle of science fair work with local kids. That's totally of the caliber.
Yeah, that's awesome. I was surprised.
That's not my level, right? But
yeah.
Okay.
I mean, really and truly, this is over and beyond the Call of Duty, and just the fact that you were able to find that second asteroid, I thought was really impressive.
I really like the percentage way of looking at the strength of the flex in the different filters. I think it's cool to see that both asteroids are relatively stronger in the red filter rather than the other ones.
Mm-hmm.
That's a really cool finding.
They're really similar.
And that's a really good jumping off point, I think, for investigating other asteroids, because then my next question is kind of like, okay, is that all asteroids, or is that, you know, are is Morrison a main belt asteroid? I think Ceres is. You know, is that something that is just main belt asteroids, but not the other kind? I think that's a really cool, I don't know, I think that's a really cool finding. So, good job.
Yeah, you're getting the astronomers all excited, so that's a good sign.
Good work, Asteroid Squad.
All right. And I see that Kathy has joined. Are you there, Kathy?
Hi, I'm here.
Hi, would you like to talk us through your presentation?
Oh, gee
Hey,
whiz. I have to follow this one.
You guys, we have a group here right now, so I'm going to leave in just a few minutes. But so before Kathy goes, I noticed that we have Diana and we have Kathleen on from the filters, the other filters group. So don't forget to ask them to comment on where we are, because both of these folks, and in fact Dawn as well, have collected data. I don't think have it in a PowerPoint form. I haven't been able to check my email today to see if anybody put some images up on the image gallery. But both Kathleen and Diana could talk about where we are with that project at this point. So give them an opportunity to do that.
Okay, sounds good. So I'm pulling up yours, Kathy.
Okay.
And just take like 5 minutes, because we actually have a few things that we have to go over at the end as well.
Oh, this will be short. That's fine.
Great. I wonder why it's not opening.
Is that a new email? Because I had clicked on all of them. So if you go to PowerPoint, all of them should be on the desktop. Let's go to Window.
Oh, this is it, right?
Yep, that's it.
All right, just let me know when you'd like me to advance to the next slide.
Oh, okay. Okay. Well, this turned out to be a really small project because everyone must have been busy in my group. So by the time I figured out that no one else was going to be taking images, I only had 3 galaxies that I took an image of. So you can go to the next slide. All there was a relationship between the apparent size and the brightness to maybe the distance. So I only had 3 spiral galaxies. You can go to the next slide. And this is what we did. I tried to do it not edge-on. I used the same telescope, the same exposure length, and the same filter. And I took the same part of each of the spiral galaxies, so that I took the brightest part in the center, so I wasn't going way out to the edges. And so I only did the 3, and I realized that, yeah, they weren't all exactly at the same angle, but there was a correlation. So you can go to the next slide. So what I did is I took I had my image, which is obviously the one that's not so pretty, as the one from the internet, and I also found out how far it was, and then all I did is I measured the distance across the bright part. So I had 103.85 pixels, and then the next slide, you can go to, yeah, M51, the Whirlpool galaxy, is 23 million light years away, and that had a little bit bigger one, except the Whirlpool galaxy was a really nice face-on one, whereas the M81. The previous one was more at an edge. And the next slide is also more on an edge. But that was even farther away, and that was only 79.41 pixels. So from that, I kind of got the idea that, yeah, this would work if you had a bigger sample and you kept the type of galaxies really similar, and the angle that you were looking at them, say, similar. So that was basically all I had time to look at. I was thinking at one time to do the brightness of them, but it just was like, okay, well, let's just go with this. So I think I have one more slide that just kind of makes a conclusion. Seems to be a correlation, but are they the same size? More things to measure. So it was just kind of fun just seeing that everything I did was brought up another question, and I could keep on going with it. So I'm hoping that as I introduce this to the kids that we learn together. So that's it.
Great, thank you,
Great job, Kathy.
Very cool. Thanks. Thanks so much, Kathy.
Yeah.
Thanks, Vivian.
So is there anyone on from that last group?
Yeah, that was the filters group. I think, Diana, are you there? And who else was in that group?
I think that was Kim Prindle and Mason and Philip and Ian Meeker.
That was my group. That
was
my group. And I don't think anybody's there from that group except for me.
Oh, okay, sorry. We're moving on to the next group. Sorry about that.
So this is Diana, and I am here. And we didn't put a PowerPoint together. What we did, I think that everybody just got really, really busy, as most of you know, with your groups. So it took us a while to get figuring out what we were doing in the first place, and then we had to go through and we had to pick what we were each observing. Our question was, what can I learn about an object by using different filters, and which filters are better for objects composed of different substances? And I know everybody was doing a different thing that they were observing, so we didn't figure out the data we all collected together, but I did the galaxies, and I don't know, for me personally, I wanted to find out more and just utilize those filters more and figure out what they were doing, which is why I wanted to get on this project, because I think it's really cool how you can see different things in the filters. Not that I did a lot of research on it, but anyway, I don't have much to report other than the fact that the filters are awesome, and I love the fact that people who were here before us, they were the ones that figured out that, oh, if we put red on, then we can see this. And so I don't know much more I don't have much more to report than that. Sorry.
Well, I have a question for you. Did you look at different kinds of galaxies?
I did. I took a whole bunch of different pictures of probably 20 different galaxies, but I kind of did the same filters on most of them because I was trying to figure out what time length I should do for each one. And because for me that's a big question too, and I know that other people kind of talked about that today, is what time length should you do for certain things. So I kind of went through and I said, okay, let me figure out time length with one filter, and then go through and take pictures with other filters of that same object at the best time. Because for me, if I had a little, you guys have been wonderful and given us a lot of time on these telescopes, but if I was a person that didn't have much time, then that's how I would have gone about this, is I would have said, okay, I only have 20 minutes on this. On this particular telescope, I want to make sure to utilize that time best I could. And to me, that would be figuring out what exposure time is the best, and then figuring out the filter part of it. So that's what I did for my part of it. And like I said, I took pictures of I think I tried to take pictures of 9, and I got images back of 3 or 4 different galaxies. But then, if I would have had more time, I would have gone through, and because I didn't get to the, on most of them, I just got to the, okay, let's figure out what time is the best exposure time, and then go on to the next part of my observations.
Great.
Does that make sense?
It does. And you know what? You can keep working on it. We would encourage you to keep working with your groups. We know that we gave you this assignment with kind of short notice, and we really appreciate that you all just dove into it and did what you could. So you've all done an excellent job, and we encourage you to keep going. And that is a good transition for this last bit.
Except, Anna, I want to jump right in here and say that I was looking over how many images everybody's taken the other night, and Diana, you are the winner. You have taken 53 observations. I didn't count all your images, but
yeah, I've had a lot of fun with it.
Good. I'm glad you are. So, you know, if you're looking for an observation, go look in Diana's directory, because you'll probably find whatever you need.
Thanks.
Sorry, Anna. You could. I had to just say that.
Open it. I usually just double click on the attachment.
All right. So I'm trying to pull up.
I can close the ones that are there. And go.
So the last thing that we want to go over is what we want you to complete in order to have sort of graduated from the workshop, and to have us set up a group account for you. So I've listed out those requirements. I'm trying to open them.
Different version of PowerPoint, maybe.
I think it was still open though.
Yeah.
All right, sorry for the delay. Okay, so in order to receive that Skynet Junior Scholars Leader account, so that you can set up a group with the youth in your group, and get them accounts and allocate them telescope time, which we talked about last week, we want you to complete the following tasks. And many of you are in good shape and have already done all of this. This is just, making sure that you have experience using the site so that you can lead your youth in doing the same. So we want to make sure that you've requested at least one image, and as Vivian pointed out, many of you have requested dozens of images, so you're in good shape. Added one to the Skynet Junior Scholars Gallery. Opened an image in Afterglow. Completed at least 2 of those explorations on the Skynet Junior Scholars site, and those were the ones we were doing throughout the workshop. So, and that includes the notebook posts that go along with them. We want to make sure that you've chimed in on the astronomy, or on the workshop forum. One post in addition to your personal introduction. You all posted introductions. Contributed to your group project in some way, and most of you on the call have done that. And we encourage you to keep going with the group projects. Some of them seem like they're still a work in progress, and so this will give everyone a chance to jump in and contribute in some way. And then we have a few surveys we want you to complete by the end. Last week's weekly survey included questions about info we need to set up that group account, so you'll want to be sure to finish that one. There'll be another another survey asking for feedback on the workshop, like the structure and the elements of the workshop and how we can improve it next time, because this was our pilot. And some of it we were working on as we went, so we could really we loved your feedback on that. And then there'll be another post-workshop survey more on what you got out of it and what you learned from it. And I'll be posting links to all 3 of those, as well as this list. I'll post in the forum so you have it to refer to. And so in order to make sure that you've completed all these tasks, we're going to ask you to summarize them and send an email, and I'll post that address as well, answering the following questions. And this list will be up in the forum, so you can refer to that. I'm going to go post it right after this call. How many images have you requested, and how many were returned to you? How many did you post in the gallery? How many did you open in Afterglow? Which explorations did you complete? Did you post messages in the workshop forum? Briefly describe your contribution to your group project, and did you complete those 3 surveys? And we'll do a quick check to confirm what you're reporting to us. And we ask that you complete these by March 15th. So that gives you a few more weeks to wrap things up. We know it was at times a fast-paced workshop, and all of you are very busy and have a lot of other things on your plate. So you have the next 2 weeks to work on wrapping up all of these tasks. Does anyone have any questions about that?
I would say, this is Vivian, that I know many of you have many observations and images within those, so you can just list how many observations you have or give us an estimate. So those of you who have been like kind of going crazy, doing a lot, you can give us estimates. We know you've been busy.
Right. If you're not sure on numbers on some of them, that's fine to just estimate. Any other questions? All right. Well, thank you, everyone. This has been a really fun workshop. You've been a good group to work with.
It's Catherine. Can you hear me?
Hi. Yes. Hi, Catherine.
So before Sue-Ann left, she just wanted me to make sure that we talked a little bit about action plans, at least for a minute or 2. Do you think there's a little time for that?
We're at the top of the hour.
Okay. Well, maybe I'll just mention that going forward, I guess we want everybody to have like an action plan for how you might recruit youth to participate, and how you might get students interested and help them out. Maybe despite some certain confusions or difficulties you've had yourself, or maybe I don't know. Just if anybody has ideas, maybe you could post them to the forum or something, or maybe we could start a discussion about that.
Yeah, why don't we start a discussion thread about action plans?
Okay, sounds great.
So what we'll start that thread tomorrow, and then people can chime in as you are wrapping up your project and thinking about how you'll work with your youth on it. So we officially end tomorrow, but it's fine if the discussions keep going in the forum, and you should reach out to any of us with any questions. And like I said, you have until March 15th to wrap up these other tasks. And as long as you complete it by then, we will set up a group account for you. Okay.
So are you? Can I have one question?
Oh, yes.
So then that means after March 15th you will set up the account?
Well, this is Vivian. So as soon as you've so it takes a little bit of work to get the account set up. So once I know your group name and feel that you are ready, have accomplished the tasks that we've sent out here to make sure that you're ready, then I'll go ahead and create that account, but then I have to also distribute time to that account. So I think one of the questions in that recent survey was, when do you anticipate starting? So feel free to email if you're ready to start yesterday, so that I can get on it, or you know, and I think this is going to probably take a little bit of one-on-one conversations with people as they get started. And we are here to help you once you get your group going. So we're not going away. And if anybody feels like, wow, this has been a really fun workshop and I learned a lot, but I'm not ready to start with kids, that's an okay answer too. So, you know, we're here to help and realize that it's, you know, all of this is new for everybody too.
Yeah, and on the surveys, be sure to let us know why you think you're not ready. You know, if there's something that we could do in the workshop to help you get ready.
Thank you, Vivian.
You're welcome, as always. And you guys you're just a terrific group. And I'll tell you what, the group projects were a riot, actually. I loved it. I love being your mentors. I'm going to be a mentor for every group next time. Oh, I don't know. That might be too hard.
You're a glutton.
No, it was actually really a blast. Somebody else had a question, though, I heard.
Other questions?
Can you hear me?
Yes.
I suggest that they have probably seen enough that they could just give their kids an account and learn it together.
So I think that's Kathleen Roper talking, right?
Yep.
Yes, it is.
And Kathleen, yeah, go ahead, Kathleen.
We've learned a lot just doing it together and figuring out what are we looking at and looking things up, and I think that's where you need to start.
So Kathleen's saying be fearless.
I think that's a really important encouragement, is that you don't have to be an expert on this to get kids going on it, that you can be learning together. So, right? But we want to make sure that you've gotten through some of these basics. All right.
True, and I think this program has been terrific because I've been doing this for a while, but I've learned quite a few things. So thank you very much.
Well, thanks to all of you for jumping in and being our pilot group. It's been fun, and we will keep in touch.
Thank you, guys. It's been fun.
Okay. Good work, everybody.
Bye.
Thank you.
Bye.